Hello, everybody. Whoa. Is that a little loud? Testing. All right. Well, welcome to the second to the last session time of TechEd. Everybody looks awake, excited. You're not looking forward to the party tonight. You're excited about two more sessions where you can learn. And you weren't out drinking your sorrows away because the Penguins lost last night. Welcome to how Microsoft monitors applications using APM, Global Service Monitor, and Visual Studio Web Testing. I'm Charlie Satterfield. I'm a senior program manager on a monitoring and management team in the Cloud and Data Center Management product group. Today, I want to talk to you a little bit about how we use web availability monitors, Visual Studio Web Tests, and APM, some of the best practices we've learned, some of the benefits that we've seen, also some of the challenges that we've had to work through. We'll start off with a little bit about my team, monitoring and management, just to give you some context of what I do, what our team does, how we think about monitoring. We'll talk a little bit about what options are in System Center 2012 SP1 as far as out-of-the-box app monitoring. We'll talk about application monitoring in action with a few demos, and then we'll talk a little bit about some of the challenges and changes to our environment that we had to implement in order to fully leverage these features. So a little bit about monitoring and management. Like I said, we're an operations team that exists within the Cloud and Data Center Management product group, and we provide monitoring and issue escalation service for many of Microsoft's large external web properties, including Windows Update, Microsoft.com, MSDN TechNet, Windows Intune, and many more. We do this leveraging the System Center 2012 data center stack, and we're monitoring about 9,000 servers around the world, including 30-plus hosted Azure services, many different web properties, and databases. On average, we generate about 3,000 incidents a day. Some days we see spikes when we've got properties go down, but on average, we're about 3,000. A little bit about our team structure, because I usually get this as a follow-on question. We have a Tier 1 team that does a lot of our first touch resolution or escalation. We have 40 vendors that are split between Redmond and India, and they have a 15-minute SLA to resolve or escalate to the appropriate business group. There's one full-time manager for that team. We have a Tier 2 team that sits with us in Redmond that's 4 vendors, and they do the daily running of the business, keeping the service online and up. We have a Tier 3-4 team that includes 4 full-time service engineers, and these are the engineers that are testing out the latest releases. They're developing some of our custom monitors. They're really doing a bunch of our forward-looking work. And then we've got myself, a program manager, and a service manager that are driving the projects as well as maintaining the relationships on a weekly or bi-weekly basis with all of our customers. A little bit about how we think about monitoring. Let me stop real quick. Because it's a smaller crowd, I encourage you to raise your hand and ask questions at any time as we go through this deck. I think it'd be a little better interactive since there's, yes? How many incidents make it to Tier 4? I would say actually the majority of incidents go to Tier 2, 3. I would say less than 5 or 10% make it to Tier 3, 4. So a little bit about how monitoring and management thinks about monitoring applications. We think about it from 2 different perspectives. An inside-out perspective, which is really about app-level monitoring based on events and counters that have been developed within your application. And this is leveraging custom MPs for unique application events, and then also looking at some of the hardware OS and service components through retail MPs. This is really looking at it from the traditional operations manager agent perspective and leveraging those events and WMI queries. Next, we think about it from an outside-in perspective. The outside-in perspective being, what is the end-user experience? Is the web application available? Is the web service available? Can I actually execute some of the core paths using either synthetic transactions or pages that execute web services behind them? And this is leveraging third-party URL monitors or custom dev URL monitors in our previous service offering within our team to our customers. Lastly, on the outside-in perspective, you may have a view of the application health from a single point of presence, but really what you're looking for from an external-in perspective is, what does the experience look like from multiple places around the world? In our case, we're looking at it from what is the experience in different regions, because the web front end may be slightly different in some of those areas. And click, there we are. So what comes out of the box in System Center 2012 SP1 as far as app monitoring? Well, you've got the old school web application transaction monitoring, which has been around since the 2007 days. But you've also got some new things. You've got web app availability monitoring, you have Visual Studio Web Tests, and you've got application performance monitoring. Now, I'm going to step through each of the last three items there and give you some more information about how we're using those internally. Web availability monitoring you can use from two different perspectives. You can use it from an internal watcher node perspective, or you can leverage the new global service monitor that was launched with the release of SP1. Internally, our application owners and engineers typically have three types of tests. They've got a URL test in which they're measuring the overall availability of that externally facing URL, and they're leveraging Global Service Monitor for this type of test. And it's providing the availability percentage as seen by various regions that they've selected from Global Service Monitor. Next are VIP and DIP tests, virtual IP and dedicated IP tests. The VIP test is tested from an internal watcher node, and a failure of this test indicates a failure of that particular site with multiple computers or servers behind it. The DIP test is a test that goes against an individual IP or server, and a failure of that test indicates that that particular server is offline or a problem with the web app on that page. Now, those bottom two tests we execute from web watcher nodes. They can be agents, they can be gateways, they can be management servers. In our case, we're actually creating resource pools out of gateways. We have at least 2 gateways in every resource pool, and this gives us high availability in our test method, so that when we're patching, we can bring one down at a time and we're not affecting our overall availability percentage for those internal tests. And it's something I'd recommend for you as well. So let me jump over real quick and do a little demo as far as creating these tests. Again, raise your hand as I'm walking through here if you've got questions. So let me switch over. All right. I'm in the Operations Manager console, and if I jump over to the authoring workspace, you can see here I've got web application availability monitoring. I've got 3 monitors that I've already created, but I'm going to create one for this demo as well. So let me click Add Monitoring Wizard. And auto-hide that test bar so that we can see the full screen. All right, next. I'll provide a friendly name. This is really for the monitor or the test collection. So I'll call this test Microsoft.com demo. And next, select a management pack. I'll go ahead and select this management pack. One of the things I'd recommend as you create your web tests, if you have some web tests that are externally executed by GSM, some that are internally executed, I divide those up into 2 different management packs so that you can remove those GSM tests quickly if you need to modify any of the settings for GSM. So I'll go ahead and click Next. And then at this point, I can add one or more URLs into this form. So I can go ahead and click Microsoft. I can type Microsoft, and I'll type the URL that I wish to test. So I can add multiple of these. Alternatively, I could have clicked on the Add button, which would have opened up a window for me to search for a CSV file. You could collect all your tests that you want to execute in a CSV file with 2 columns, name, URL, and import it in so that you don't have to type it over again and you can manage it offline. So for the purpose of this demo, I'll just test Microsoft.com. I'll click Next. At this point, I've got options. I can either test externally through Global Service Monitor, or I can test internally through the resource pool that I've created. So let me show you the Global Service Monitor option. If I click Add, I can go ahead and start to type a name and click Search to filter the options, or I can click Search to return all of them. And as you can see here, there's quite a few. I believe there's 16 around the world. And I can go ahead and select one or more. In this case, I'll select all US, and then I'll select London, and I'll click Add. And I'll hit OK. Now, alternatively, I could execute at the same time from an internal location. And when I'm selecting an internal location, it defaults to searching for agents. In our environments, like I said, we're using resource pools, and this makes it easy for us to actually manage the tests, and it's a smaller set of results that you have to search through. I'll go ahead and click Search, and you can see here I've got a watcher node pool that I've set up in our Quincy data center up in Washington. And the location is something from GSM, it's auto-populated. Within your infrastructure, you actually have to use PowerShell commands to add a new SCOM location, and then associate that location to either an agent, gateway management server, or resource pool. So I can click Add if I wanted to add this, but I'm going to go ahead and cancel. I just want this to run externally. Click Next. Oop. I click Next twice. So on this next screen, I get a summary of all the tests that are going to be executed by this monitor. A test is considered a unique URL and location pair. And then I can see here that my test frequency is set up to run once every 10 minutes. Now, the most often you can run this from GSM is once every 5 minutes. If you're executing an internal test, you can execute it very quickly, every 20, 30 seconds if you so desire. What we've done internally is actually run it every 2 minutes for most of our customers when we're running from an internal location. So to change that, you click Change Configuration. So this is set up to be 10 minutes. I'm going to change this to 5. I can also determine or specify how often I should be collecting performance data. Should I collect it on every test? Should I collect it every other test? I can specify test timeout. I can then specify some of the alerting criteria. You can see here I've got an error health state criteria set up for this HTTP status code. I can also have a warning health state indicator. Like I mentioned, we're running every 2 minutes from internal locations, but we found that every so often we have some network hiccups and we get false alerts if we're failing or we're generating an alert on every failure. So what we've done internally is we actually up the consecutive times the criteria should fail from 1 to 2. So it's going to test twice in a row, and if it fails both times, it'll generate that alert. The next section here is important. I can select either generate an alert from each test, or I can generate a summary alert. Our internal partners are leveraging the generate alerts from each test because it gives them a clear indication of where the failure is in regards to the location they're testing from. If you use the summary alert, the information in the alert doesn't give you enough detail to get started on debugging or going to triage. You have to come back into Ops Manager to get more information to help you out. So I'm going to leave this at generate alerts from each test. The next section includes a bunch of performance collection information. This is the default that's provided when you set up a monitor. And then there's a little bit more as far as general configuration and the ability to actually modify the HTTP headers of the request. So I'm going to go ahead and click OK, because I've made some changes that I want. And so now you can see my test frequency is once every 5 minutes. And if I go ahead and click Next, yes? Yes, yes. So the question was for those watching the video, when I modified the configuration, it was for all of the URLs that are being tested, or all the tests, not just the one that had been highlighted. All right, so at this point, I can go ahead and click Create. It's going to go off, and it's going to add this information into the MP that I've selected, and then it's going to re-import that MP. Within about 10 to 15 minutes, I will start seeing data coming back to me from Global Service Monitor. If I were executing an internal test, I would have results probably within about 5 minutes, or depending on how quickly or how frequently I've specified the test should run. So that's how you provision one. Now, what kind of data do you get back? So flipping over to the monitoring workspace. Yes?
So when you created that, that's a very simple public website type of monitor, right? How do you get to a more complex, I have to do a login, I have credentials, I might have cookies that they're looking for, and like ADFS login, for example. How would you do an ADFS login through this when it expects to run JavaScript?
So ADFS, when running an internal monitor, we've been using a combination of the old school web transactions, which allow you to specify a unique run as account for each transaction. And then we've also, you can modify the privileged account that's used to run the internal tests for web app monitors, and specify a global account or a domain account to be used for ADFS authentication. This really is more of an HTTP ping, so it will auth and tell you whether that page is available or not. It won't actually go through transactions. We'll get to transactions in just a moment. Any other questions before I move on? All right. So on the monitoring workspace, I'm going to go ahead and expand to application monitoring. And there's a couple folders underneath here. One is Web Application Availability Monitoring. And if I click on Web Application Status, I can see here I've got 3 of the monitors that I had already created that are returning data back to me. They're all in a green, healthy state. Now, I can also look at test state. And test state shows me the unique health state for each of the tests within those monitors. And you can imagine, if you have a lot of monitors and a lot of tests in each monitor, this view can be very large. In our Windows Update environment, we actually have, I think, close to 7,000 unique web tests that are being executed right now. This view takes a while to load when you have that many. I'd recommend that you create custom scoped views to go after the URLs tests that you really want to go after if you want quick access to this. All right. So going back to the web app status, you can see here I've got testmicrosoft.com demo. It's appeared, but it doesn't have any data returned yet. So let me go into one that does have data. I'll go to microsoft.com. And under the task pane, I've got 2 different dashboards here that are useful. One is a summary dashboard map. And if I execute that, it brings up an image of the world. And within a few seconds here, you should see all the locations that I'm testing from and the health state from each of those locations. Give it a moment. Oh, and there we go. And let me bring this in a little bit. And I can go ahead and, as soon as it catches up, there we are. I can go ahead and select multiple locations from this view and see the transaction response time and the last sample time of the test that was run. So useful as far as a heads-up view to understand how it's operating from various points of presence, from either GSM or from your internal management servers, agents, or resource pools. You do need to add locations to your internal agents or resource pools before they'll show up on this view. The other dashboard that's interesting is the detailed dashboard list. The detailed dashboard list shows you all the locations that you're testing from, and then if you select them on the left, it'll display the tests that are executed. So if I go ahead and select a few of these, I begin to see some of the performance data that's being collected by each of the tests. And you can see here, I've got total transaction time, time to first byte, content size. What I'm really looking for here are spikes. Am I seeing anything out of the ordinary? I do see I've got on content size a couple dips there, and that's out of my Los Angeles point of presence, so I'm not sure what's going on there. I may need to look into that. And then content time from Singapore appears to be much higher lately than the rest of those. So those give me an area to focus in as far as some problems that my application may be having from a particular region. Now, lastly, come on, get out of there. The other thing that's important, I'm sure to you, and it is important to our internal customers, is the ability to report availability data for these applications over time. There is, if you select one or more of these application monitors, a report down here called Web Application Availability. Now, if I click on that, that'll open up an SSRS window, and it will be pre-populated with the object that I had selected. Now, I can specify my aggregation, and then I can also specify from what date to run this report. So I'm actually going to run previous week, and I'm going to go Friday to today, and I will run this report. Now, in this case, my availability was 99.76, and I see a very large green bar. Now, if I dive into this, let's see, let me expand this out. Let me dive further into this so that I can see, yep. The further you dive in, the more data you'll see as far as some of the downtime that you've experienced. And you can see here that I've experienced a little bit of downtime yesterday and a little bit of downtime today. And I can dive in further to actually understand exactly where within that day I experienced some outage. And you can see here, it was around 1 a.m. this morning, I had a dip. Now, the one thing you don't get with this, while it is good data to be able to report back up and understand what your availability is, you don't have the ability to click right from this data to get to the alert and issue that caused this downtime. You do need to go back into the OM console, and you need to go into Health Explorer for this particular monitor and go down to the test object to determine where that health state changed and what the root issue was. So, any questions on web availability monitoring before I move on? Yes. Yes. Your management server does need access to the internet, either directly or through a proxy, yes. So the question was, for those watching the video, does the management server need access to the internet in order to set up a global service monitor? And the answer is yes, either directly or through a proxy. I believe there's specific ports you can open. I don't have that on hand, but yes. All right. So one other thing, let me go actually to the admin tab. When you install the Global Service Monitor MP, close the console, reopen the console, you're presented with this in your administration view. Global Service Monitor. And you can see here it gives me an indication of, I can come here to find out the usage of my available tests. And you can see here I'm using 12 web app availability tests with GSM, and I'm using 8 Visual Studio web tests. There are limits. When you first sign up, I believe it's 30 web tests and 30 Visual Studio web tests for your trial account. When you move it to a paid account, and paid is basically you have an SA agreement. It comes free with that SA agreement, and you can request a larger size. Sorry? The upper limit, unfortunately, I'm not aware of what the upper limit is. I'm a consumer of the service and not the owner of the service, so I don't know what the upper limit there is. All right, so that's web application availability monitoring. Let me jump back over to the deck for a moment. So some of the benefits that we're experiencing are the ability to provision an app monitor that has multiple tests or multiple URLs. Previously, with the old transaction monitoring, you had to create a monitor for every URL you wanted to test. This is a lot better. It's easy, especially with the ability to add a CSV file along that wizard path. It's also easy to provision tests to both an external and internal resource. It's all the same UI experience. You don't have to learn two different experiences. You get the automatic health roll-ups of Operations Manager. You get the availability and performance dashboards. These are particularly useful as far as looking at in a daily stand-up type environment to be able to understand where the performance hits are coming from, and any application downtime you may have experienced. And then lastly, the availability reporting, the ability to actually specify one or more monitors to roll up into a report, and then generate that report for your own team or for management. Lastly, it is free if you have an SA, and it's saving our internal customers as much as $600 a month per URL monitor. So it is of fairly significant value to our customers. We do have some challenges, however. So I did mention that the Windows Update team has about between 6,000 and 7,000 unique tests. Those are housed in, I believe, 400 unique test collections or monitors. When we want to change some of the settings that we found along the way in the wizard, we actually have to go back into each one of the monitors and make that change. So there's no PowerShell today that lets me go in and automatically go through and modify that per monitor. So it becomes a little bit of a challenge when you have a large number of monitors and tests you've created. Next, I highlighted as we walk through, I don't have the ability to view the issue or alert that caused the downtime when I'm looking at the report in SSRS. And then I don't get a breakdown of the performance of each of the page components. I just get an overall page performance statistic. Next, I want to talk a little bit about Visual Studio Web Tests. Visual Studio Web Tests are used by our app owners and engineers to actually do transactional tests, to do tests that require a form-based login, to be able to validate content as well as expected URLs, things of that nature. I'm not going to go through some of the considerations here. These are available in the deck, and they're available also on TechNet. The one I will call out is, in order to actually use Visual Studio Web Test, import a web test file, and have it be executed by Global Service Monitor, you need to make sure that your think time parameters for each of your steps are set to 0. Global Service Monitor does not support a web test that has a think time greater than 0. So now I want to step over and show you a little bit about how to create a Visual Studio Web Test. Yes?
So can you use this on-prem from your internal agency
It's an excellent question. I'm getting to that, but the short answer is unfortunately. So the question was, can I use these tests from internal watcher nodes and not have these restrictions? The answer is no. Today, Operations Manager does not support running these tests internally, only externally from Global Service Monitor. All right, 1 second here. All right. So setting up a test is very similar to setting up a web application monitor. However, you're going to start in Visual Studio to generate what you're testing. So let me switch over to Visual Studio. So in Visual Studio, I've created a web and load test project. And from within this web and load test project, I'm going to go ahead and add a new web performance test. As soon as I do that, a new IE window opens up, and I should begin recording, although I don't see the window. Nope, I'm not getting that. So let me. Sorry about that. At the last minute, I decided to change environments that I was running in, and it didn't have that ActiveX control loaded. All right. So from within my web and load test project, I'm going to go ahead and add that web test again. Web performance test. And here you can see my ActiveX control has been loaded. As I begin to type and navigate through the page, it will record all of my steps. So I'm going to go ahead and go to Microsoft.com. And you can see on the left, all my steps and the different page components are being tracked and recorded. Next, I'm going to go ahead and search for Windows 8. And once I get my search results, I can go and navigate through these if I like, but I'm going to stop for this demo. And when I stop, I'm returned back to Visual Studio. And what it's doing now is detecting any dynamic parameters that were found as it was recording that web test. And it is important for the purposes of executing your test. If it does find dynamic parameters, do promote those to dynamic parameters. It's important in cases especially when there's form-based login. So in this case, it did not detect any dynamic parameters. So let me close my test results. You can see here all of what had been recorded. And then I've got some, let me scroll down, validation rules that are global at the bottom here, that it checks to ensure that the response URL that it collected during the recording is the same as what it experienced when it executes the test. It also has a response time goal. So you can change these globally from this point. You can also add validation rules to individual steps. So in this case, under search.microsoft.com results, I actually want to add a validation rule. So I'm going to add a validation rule to find some text, and I'm going to look for the text windows to make sure that the search results that came back are what I expected. And then I'll click OK. And you can see my validation rule has been added underneath this step in my web test. So I can go ahead and execute this web test just to make sure that it's going to succeed. I don't want to import a web test that's going to fail locally on my machine. Yes.
What is it tracking right now?
I'm sorry?
It's sending some requests, and could you describe what is happening right now?
So it's sending the requests, and then it's checking to make, so those two validation rules that I talked about, it's checking those validation rules. So when it sends the web request, the URL that gets returned back, it's validating that it is what it recorded and it expects, and then it's validating that the performance load time for each of those steps is underneath the overall performance validation rule that's specified. Yes? I believe it requires Visual Studio 2010 and above. So it's built into Ultimate and I believe one other version to get the web tests. If you have the version that includes the test manager and some of those extra testing tools, I would believe it's included in that version. Another question.
Yes. So you mentioned that you need to create a load test before running, specifying before you're recording going to Microsoft website. Or what you demonstrated just in the previous minute, that's all you did.
So what I demonstrated is essentially I added a web performance test to my project, and as soon as I added that, it opened up an Internet Explorer window with the ActiveX recorder enabled. And so as I went through that process, it was capturing all my steps. So as soon as I closed it, I was now back into Visual Studio, and I saw all my steps. Yeah? So yes, you can do some similar validations and step through some transactions using the old transaction monitor, but that you can't upload those to Global Service Monitor. Were there any other questions before I move on? Nope? Okay. So now that I've added a validation rule to my web test, and I've run it and it's passed, so this is my test results. The next thing I want to do is set my request details to make sure that I've set my think times to 0. And because I was pausing a few times as I navigated through, you can see I do have a few think times greater than 0. Okay. So let me go ahead and file and save this. And all right, so I've saved this. Now my next step is to go back into Operations Manager. So let me go over to my Operation Manager console. And you can see here I have 2 Visual Studio web tests that are already executing, but I'm going to add a new one. So again, I'll step through the wizard. And this one I will call searchmicrosoft.com. And I will add it to that same MP. Now on this screen, it's a little bit different. On the web app monitors, you were able to specify one or more URLs to test. Here, you're able to specify one or more Visual Studio web tests. So I can actually add one or more. So in this case, I'll just add one, but I could add several tests to this one monitor. So I'll go ahead and click Next. Now, this screen also is different. As I mentioned, you can't run these from an internal watcher node or resource pool or agent. You have to run these from Global Service Monitor, so you only have the ability to select external locations. So I'll go ahead and search external locations, and I'll go ahead and just run this in the US. And I'll hit OK. When I click Next now, it again shows me that overview of the individual tests that this monitor is going to execute, and the location from which they'll be executing. And you can see my test frequency is set to 10 minutes. I can again click on Change Configuration if I want to change this, and I can set it down to a frequency of most often of once every 5 minutes. I'll leave it at 10 for now. I can also select the number of times this should fail before it generates an alert, and then whether it should generate an alert from each test or a summary alert. All the other options that you saw on the web app availability monitors are not there because all of the configuration of the test is really within that web test file. So you can add a bunch of validation rules in that web test file that will determine whether or not it passes or fails. So I'll go ahead and cancel out of here, and I'll click Next, and then I'll go ahead and click Create. And again, this is going to go off. It's going to add all this data. It's going to grab that web test file, and it's going to add that into the MP. It's going to re-import that MP into Operations Manager and then begin communicating with Global Service Monitor to provision web tests to each of the locations that I've specified. For these types of tests, it will take a good 20 to 30 minutes before you start seeing data returned. It just takes a little bit of time. However, I have a few tests that I've already created, and I can show you some of the data that gets returned. Again, we've got a web monitor state, or the web test status, and a test state view. The test state view shows me, again, the health of a test from each of the locations that it's executing from. The other view is the roll-up. You can see here I've got a failure from my Miami point of presence for the Volume License Service Center web test that I recorded and uploaded earlier. I'll go ahead and go back to web status and show you one of the unique dashboards for Visual Studio Web Tests. So I still get the summary dashboard map, but I don't get the detailed dashboard view. What I get is a test results dashboard. Now this dashboard displays the test locations on the left, and if I select one of them, I get the test status, and if I select that, I'll get data for my total transaction time, and for any failures, it automatically downloads the test file from Global Service Monitor. And I can see all the steps and where it failed. And I can also see the performance characteristics of each of the page components that were recorded in that web test file. So you can see here, as I scroll down, select the failure, I'm not finding, so there was a context parameter that was recorded in the recording I did earlier, and it apparently is not finding that. So there's an issue coming from that region that it's not getting that parameter. Additionally, I can click on some of these others, and you can see that the request URL validation failed on this one. It didn't get the expected URL that it recorded. So I do have some problems coming from this particular region, and I need to go take a look at that. So as far as the rest of the data that you get back with the Visual Studio Web Test, you still have the ability to go into the SSRS report. So if I were to highlight one of these, I still get an availability report, so I can see the availability and roll that up and present that to my team or to my management. But it's that ability to dive into that test result dashboard that really gives you a good view of where the transactions are failing and the response time for each of those component pages. Any questions on the demo before I move into just sort of a summary of that, and then we'll dive into APM quickly? Nope? All right. All right. So some of the benefits, as we walk through the demo, the ability to record the user actions. Yes, you do have that ability in the old school transaction monitoring, but you didn't have the ability to actually execute those from external points of presence like you do the Visual Studio Web Test. The transactional and authentication capabilities, I have the ability to log into a forms-based application and navigate through that app, search. I can then check for various validation points along my recording. Validation points. Lastly, the ability to see the performance of each of the components within that recording, especially for Microsoft.com. They've got a lot of page components that they include in their pages from other providers at Microsoft. And so if there's a slow component, they want to be able to see that so they can go back to the owner of that component and go get that fixed. This is something you did not get with the web app availability monitoring. If the page was loading slow, it loaded slow, you didn't understand which component was causing it. And then, again, it's free. Some of the challenges, like I highlighted, you can't run a Visual Studio web test from an internal Ops Manager watcher node. This is something that our internal customers are asking for. It's something I've filed a DCR with the product group, and we'll see what happens there. Moving on to APM, Microsoft.com, one of our customers, is a fairly heavy user and adopter of APM. They run www.microsoft.com, download.microsoft.com, a long list of websites. And they have a large number of web servers serving this property, handling about 1.6 billion requests per day. It's fairly large. I don't put these points up to say you need to have this to be able to get value out of APM. I say this because they are able to run APM successfully. They're able to see the value that any of you can actually see. You don't need numbers to this size. The www cluster itself is running on Windows Server 2012, IIS 8, and is home to about 3,100 web applications. They've got various SLA goals. One is a platform availability goal, which is simply, is my web platform alive? So they have some test pages that get hit by GSM to understand, is my platform alive? And then they're still using Keynote for some availability testing. In this case, they're measuring page delivery, which is the actual web page, and did it completely load. So who's familiar with looking at one of these? I see a few hands. So this is what debugging used to look like for Microsoft.com. You'd have a problem, you'd take your server out of rotation, you'd get it into a debugger, and then you'd try and repro the issue. Not always guaranteed you get a repro. Sometimes it can take months before you actually find that repro, and the whole time you've reduced your overall availability. What their debugging is like today, they are using APM exclusively for their debugging of web applications. So they have a large amount of applications. There are some physical constraints with APM. You can only have APM running on 400 agents, or the APM service running on 400 agents in your management group. And it only supports up to 700 applications in that management group. They have 3,100 applications, so they can't really be using APM all the time. What they do is they're selective about what servers they turn APM on, and they have a few high-profile applications that they always have APM running, and then they'll turn APM on for other applications as they start to see some availability issues with those applications. It allows them to collect data and not have to pull those servers out of rotation. So how do they use APM? So APM comes with two consoles. One's the App Advisor console, one's the App Diagnostic console. Both are web-based consoles. Some of the key reports that they look at on a day-to-day basis to understand where they should be spending their time as far as triaging issues. One is the summary failure analysis. Now, so this is kind of hard to read. Let me expand that up. The summary failure analysis view, you basically get to the view, you click apply, and it shows you for basically the last period of time what your most problematic applications were from a failure perspective, whether it be a performance or an exception-related event. And I've deleted out some of the application names here, but you can see that I've got one application here that's generating a large majority of my problems. Focusing my attention on that application and the next app would reduce the pain points my customers are experiencing dramatically. So I can go ahead and from there, I can drill in to get the overall top 5 exception events for that application. So you can see here, I've got 5 exception events that are making up a little over 81% of my problems for this application. Now I can drill in further to those, and I get a view that shows me the actual exception that this page is hitting when the user's walking through it. And I can go ahead and click on the Actions button in the top left and download the IntelliTrace that was captured during this exception. Or I can do some other things that I'll show you in a little bit that help me move these exception events over to my dev team for quick action. So now that I've determined the application that I'm going after, I can jump over to the application status report, and it gives me an indication over time of how this application has been behaving. So let me jump to the next screen here. It's going to give me a view over the last, so my current, my previous, and my average of event count history, request time history, memory usage history. I'm looking again for spikes and for drop-offs. This gives me an indication of how this application is behaving, especially useful if I just did a deployment last week or the week before and I want to understand how is it behaving compared to previous. Am I seeing an improvement in my user's experience? As I jump down in that report, there's a top 10 new problems section. This section highlights new problems that did not exist in any of the previous results. So again, especially useful if I've just deployed new updates to the web page. I can quickly understand, am I seeing new issues that I need to go take a look at? The next area in this report is also very valuable. This gives you an indication of my problems, my most frequent problems, performance and exceptions, and it gives me an indication of whether I am improving or I'm degrading. So anywhere where I've got green, I'm starting to make some progress. Perhaps I've deployed new code last week that's really driving exceptions or performance events down. You can see my exception problems. I must have deployed new code last week because I've got 340 fewer of my number 1 exception problem. And so I'm able to track how my application is doing over time with regards to exception events. Again, I can dive into any one of these and get to the actual call stack exception event that occurred, and I can grab the IntelliTrace file. Now, one of the useful things that you can do here, and let me actually jump over. Let me jump over to my OM console again. All right. So if I look at my APM templates, you can see I've got one application I'm monitoring. For the purpose of this demo, I'm using a demo application. My customer didn't really want me jumping around in their production environment for the purpose of the demo. So I'm monitoring Fabricam production, and I've got, let me go back. I've got my application status page open, and you can see here I've got quite a variety as far as my request counts over time and what's going on there. I can look at some of my I/O history and see is it correlating to an increase or drop in requests that I'm getting, or my requests staying the same and I'm experiencing some performance issue. I can also jump again into the new problems or the top 10 most frequent problems, and I can see here I've got a problem. It can't find a file. This is something that perhaps the operations team needs to go back and take a look at. But my next one down is a null reference exception. And I know in this case, this is something that my dev team had fixed in a previous release, and it looks like they may have a regression. I can dive in to that, and it hopefully doesn't make me log back in. Nope, it's loading. It's probably going to make me go through this report one more time. Yep, all right. No, I let that sit too long, so it's going to make me go back into my app status view. So let me go back to application status, and within this view, you can't just hit apply. You do need to select the one or more apps to focus on. So I'll go ahead and select my application, and then I'll click apply, and then it'll generate the same report that we had just seen. And let me scroll down. And I can go ahead and drill into this null reference exception. It gives me all of the application failures for this particular problem and the event date. And then I can drill in further to see the entire stack again. Now, this is useful for me, but it's a lot more useful for my dev team. And I really need to just engage my devs on this. Now, the best way that I can actually engage them on this is by sending this data over into Team Foundation Server directly. So I've installed the Team Foundation Server connector in Operations Manager. And so what I can do is go back to my monitoring workspace, and I can go to my active alerts for Fabricam. And you can see here I've got a few that are active. I've already got some that are assigned to engineering, but I'm going to go ahead and actually, I'm going to grab these and I'm going to just send everything over to my dev team by assigning them to engineering. Setting the resolution state to assign to engineering is the indication to the Team Foundation Server connector that it has alerts to forward over to TFS. Now, when you install the Team Foundation connector, it imports a new template into Team Foundation Server called the Operational Issue template. This template has all the fields it requires, Operation Manager requires, to be able to forward over relevant data about this issue. So now I'm going to actually jump over as the dev team, and let me take a look and see. All right, so I can see I've got 4 active or resolved operational issues right now. So let me close out of that. And if I open up my query, actually now I'm up to 10. So it was that quick. The frequency at which the workflow runs to actually forward events over to Team Foundation Server is configurable. You can use overrides to change that frequency. I think the default is set up to be once every 5 minutes or so. It checks to see if there's any new alerts to forward over and if there's any updates from Team Foundation Server to bring back to Operations Manager. So in this case, I've got a bunch of new issues, and I'm going to select this one here. I've got an application failure on this one, and if I go into the link section, what I should see, and again, this is configurable via overrides, I should see a link back to the App Diagnostics portal, and I should also see a link to the IntelliTrace file that was captured during the APM event that was captured. Now, as a dev, I could open this up, and I'll jump right to the point in the code where this failure occurred, and I can start debugging. Alternatively, I could manage this via overrides. I could force the connector to actually add that IntelliTrace file as an attachment to my work item, It really depends on how you want to manage the storage of that log file, whether you want it to be out on a file share or whether you want it to be in your Team Foundation database. That's configurable and up to you. So as the developer, I can go ahead and accept this. And when I accept this, over on the Ops Manager side, once the workflow runs, it will show the status of accepted so that you understand that work is being done. Now, once I resolve the issue, if I go ahead and click Resolved, and I will assign this to myself, and I'll provide some issue, please test and deploy. Provide some resolution notes. When I save this, it's now going to be reflected over an Operations Manager as well. Again, once that workflow runs again, Ops Manager will pick that information up, and we'll now have my Ops team ready to go with a new build that fixes the issue. So if I were to go ahead and refresh this screen, get the tasks out of there. Yeah, so workflow hasn't quite run yet. But what you can see from Ops Manager side is that I have a ticket ID. I can understand the exact ticket ID that each of these problems has created over in Team Foundation server. So it's easy for me to reference that ticket ID and go back to my developer team, my dev team, and ask them, what's the status on this? I've got the data. It's tracked as an artifact in both Team Foundation server and Ops Manager. So this is something that Microsoft.com is using and testing out. They're excited to really leverage. They're already leveraging APM, but they're looking to leverage the Team Foundation connector in the very near future. So, any questions on this before I move to the next section? Nope. All right. So, quickly now, some of the benefits that we're seeing are we have the ability to quickly configure these monitors. All this requires really are the APM MP and the IIS MP, and based on that, it discovers all your IIS inventory, all your applications, and you can quickly search for those when you create your new monitor. We're able to profile applications for performance and exception events without modifying code. Typically in the past, we actually had to build some instrumentation into our compilation, and that was how we were able to actually get some of the data. Now, we don't even have to build that in. We have the profiler running in the background. It's a near zero touch. It's non-intrusive debugging. We don't have to take a machine out of production, try and repro this ourselves. We're able to actually repro this while it's still in production and capture the exception events very quickly. And we're able to get not only get the events, but understand how frequently our users are hitting these issues. So we've got very good data to be able to go back to our dev team and say, look, these are our top 5 issues. If you really were to nail these issues, it would dramatically improve our availability and our user experience. So it's data that your dev team will crave. Again, the statistical views, this is hard evidence to take your dev team on what they should focus on. And then that tight integration with TFS really helps establish a good linkage of workflow between your ops team and your dev team. And you're literally working off the same artifacts, and they're linked between the two systems. Some of the challenges. One, it does help to have operations resources that can read the APM data. You need to have a little bit of dev experience to be able to really take very good advantage of this, or maybe pair up with your dev team so that they're integrated with the process a little bit if you don't have some of the skill set on your ops team. Not sure this next one's really a challenge. It's more of just an FYI. You do need to perform an IIS reset before APM starts collecting data. So you can create your monitors, but until you perform an IIS reset, it's not going to start the APM service, and it's not going to start collecting data. Next, be careful. Sometimes your apps may not be discovered if they're not using the default discovery mechanisms. If they've got a blank root folder, you don't have any ASPX files or the like in that root folder, sometimes they won't be discovered. You can get around this with the use of overrides, however. And then lastly, this is more just of a wish list. It doesn't really provide insight into memory leak investigations. We still have to do the old school manner of debugging for these. But as our triage team would tell you, or our debugging team would tell you, that would put them out of a job. So they're happy for the moment, but they would like to see this in the future. It's a request that we have into the PG. I'm not sure if that's in their backlog yet or not. Real quick, before we wrap up, all of these were some tremendous features for our customers. It really gives them a good view into how their application is performing and whether or not it's available for their customers. However, we had some challenges in getting these features to our customer base. Because historically we had been a single management group that provided a monitoring service to 9 different business units, it was a bit of a challenge to be able to open up the console to everybody. We typically did not hand console access out to our customers for security reasons and to just ensure that Ops Manager was up and reliable. We didn't want folks in there adding management packs that might take the system down. We wanted to have tight control over that. Additionally, some of the product constraints really forced us to rethink how we were implementing this. Like I mentioned, there are 400 APM agents that can be active in a single management group. That really wasn't going to scale across 7,000 agents. Next, GSM, you can only associate one GSM account per management group. So that was another challenge that we had to work through. So what did we do? So we've moved now. All of our business units have their own dedicated OM environment. We still have a large shared environment that provides some failover redundancy as well as does some of the base monitoring. But all of the application monitoring is now done in their dedicated instances. So we have as many as 3,000 agents reporting to a single dedicated instance, and they now have console access to their management groups. They have a GSM account per management group, and all of them can take advantage of things like APM and GSM now. So this is how we've gone about changing our implementation to be able to take advantage of some of these great features. So I hope you've gotten some information out of today that you can use in your own environment. I hope that the web availability, Visual Studio Web Test, and APM are as beneficial to you as they are to our customers. And at this point, I'd like to open it up to any further questions. Yes? Yes. So the question was, do all of your management servers have to be connected to the internet to use GSM? Yes and no. You can specify a resource pool that GSM uses for communication to the internet. So you can scope that to a smaller set of management servers. Okay? Other questions? Yes? So to get through the additional GSM subscription, you should be able to go to, once you've established your org ID, you go back to that org ID site and look at your services. You should be able to submit a service request to request additional capacity. So it should be fairly painless. I don't know, I haven't walked through that exact hoop myself, so I'm not sure. So out of the box, for your trial, you get 30 tests for both, 30 tests for web availability and 30 tests for Visual Studio. Yes? Yes. So we actually have, it's beyond the scope of this deck, but all of the alerts generated by our ops manager management groups flow through to Service Manager. We actually have a custom routing engine that we've built off to the side of Service Manager that handles routing incidents based on metadata that we've built up about those servers. It's a homegrown instance, yes. Yes. Thank you.